Well, I tell you, honestly speaking, all it takes is 6 to 8 months of your precious life. And I swear to God, you're in the game for 120 to 150K. And this 6 months is not sleeping. It's all awake. It's all hard work. It's all sacrifices. If you can give me this, I promise you, I will give you this. I don't care who you are. I don't care what your skin color is. I don't care what your age is. I don't care what degrees you have. Look into this. What we're going to do today is basically, we were talking about networking yesterday. And in the networking, I talked about, let me just stop over here for 1 second. I talked about how every machine has a network card. And every network card has to have an IP address. And that's just, a number which is assigned by what? A DHCP server. The DHCP server is a machine on your network that sits on your network, and its job is to assign IP addresses. Assign network configuration. The whole thing. Network configuration. And what is that network configuration? That network configuration is this right over here, this information. Yeah. We are definitely going to schedule a meeting to get to know you, like I said. Okay, so let's talk about this stuff over here, okay? The network configuration involves IP address. So DHCP will give your network card, which is located on your machine, an IP address along with subnet mask. This is a review, by the way, and then also default gateway. So I can put the whole name over here, default gateway. And also DNS. Beautiful. Now, DHCP assigns this network configuration, these numbers, to your network card. Now your network card can communicate with the other machines on the network, provided that it has the RJ45 cable plugged in and it's going on the other end to the switch. Okay. All right. So you guys are good with this stuff? You understand this? So every machine that's on the internet today is working the same model. The only change might be that in some corporate environment, they prefer static IP addresses versus the DHCP. And we're gonna learn how to set up the static IP address as well. How to set up the DHCP and how to set up the static IP address for our network card, okay? So that's something that I wanted to make sure that you guys understand. IP address enables you to communicate with other machines. Subnet mask tells your machine, the machine that you're talking to is on your network or is on a different network. Default gateway also, once, because you have a destination IP address where your packet is going, when let's say google.com, you have that IP address. And then the subnet mask will say, okay, this is a different network. Default gateway will take your packet outside of your network and hand it over to the next router. And the next router will give it to the next router. Next router will give it to the next router. How do we know how many routers your packet goes through before it reaches the destination? There's a command for that. The DNS helps us to translate the IP address into the host name. Host name basically is all the computers, networking devices, whether it's a laptop, printer, desktop, or a server, or any machine that's on the network, it has to have a computer name. It has to have a name, and that is called host name. So I will be using that term a lot, host name. DNS job is to translate the IP address to the host name and host name to the IP address. As long as you have all of these settings for your machine can communicate with other machines perfectly as long as it's connected to the switch, which is connected to the router. Physical connectivity is very important. When we're talking about the home networking, this is replaced by the Wi-Fi card. This is replaced with the router in your home. Everybody's good so far? Okay, very good. Now, I'm gonna just erase this one, and we're gonna look into some network troubleshooting. How do we know systems are connected to the network or not? Okay, how do I know my server's cable is plugged in to the switch or not? It's connected. There's a cable connected. So I'm gonna share my screen now. We're gonna get into the command line. I want you guys to go ahead and open your os.linux, os.linux, and log into your terminal quickly. And let's get the ball rolling over here. If I can remember my password. There you go. Let me see over here. And did I work with this one? There you go. All right, good. So I got my thing. It's reconnecting. You have to hit the refresh button to reconnect, okay? Now I got my terminal over here, and now I'm gonna use the command nmcli. As you can see over here, it says connected. Connected, that means my connection is good, my connection is connected. As you can see over here in the, if I can take the snipping tool over here, I want to show you these settings, which is very important for you guys to know that all of these interfaces that we are looking at, let's say we're going to look at two interfaces over here, the two network cards over here, both of them have the things that we talked about. You know, it has an IP address over here, and this by the way is the IP address, and this part over here, this is your subnet mask, and then it has the default gateway over here. You understand that? And if we go further, because this is a short command, if we type in the command right over here, I invite you guys, press Q and type nmcli dev show. nmcli dev show. And now if you look at this output over here, ladies and gentlemen, if I elaborate on this one, we're gonna see one interface. It has a lot more information, elaborated information. Dev show, nmcli dev show will give us the elaborated, more detailed information about our interface. And what information we're looking at over here, let's start with the interface name. This is the name of the network card. It's the Ethernet type. This is the MAC address. This is my IP address over here. This is my default gateway over here. And ladies and gentlemen, this is my DNS IP address over here. This is my another DNS IP address over here. And so you can see, and it says that it's connected. That's how you can tell that there is a cable and it's connected on the network. So nmcli dev means device show. That means, hey nmcli network management command line interface, go ahead and show me all the interfaces and their information in a detailed way. All right. So now we know this part. We're gonna basically go ahead and check our connectivity with other machines. So I'm gonna press Q over here and I'm gonna do this. Cancel this out. Okay, so in this one, okay, I am going to use the ping command. Remember I told you about the ping command yesterday, and I'm going to use the host name pinggoogle.com, and that's how I can tell whether I am my machine is able to reach google.com, which is a server on the internet somewhere in the United States. And now I'm going to press Control C to get out of this. Control key and the C key together. That means terminate this command, whatever I was running. So press Control and C. When you use any command, please give us 2 minutes for using this command on terminal. Okay, I agree. Yes, sorry about that. I appreciate that. You guys keep me on track. You know, naturally, I'm a very slow teacher, but I get a lot of pressure from my students saying, hey, you're lousy. Come on, old man, get it moving. Come on, move your fingers, man. You're such a slow dog. And so, you got to show something in your defense, okay? And so instead of being called an old dog, I like to move a little faster than, they give me something to focus on. So now, let me ask you this question. We are connected to our network right over here. We got a machine over here, draw. We got a machine A over here, machine A over here, machine B over here, machine C over here, machine D over here. There's a switch in between, and they're all connected to the switch. And then the switch is connected to the router, and the router's job is to basically any one of these machines that want to go outside, they decide that they want to go to, let's say, google.com, right? Then the router basically takes that packet and sends it to google.com, and in between you have a lot of routers, okay? And so this is your default gateway, okay? This is your default gateway. Now Control C is basically to terminate the command. For example, when you're running the ping command and it's constantly running and you need to get out of this ping command, you see it's constantly running and you want to stop this, you want to get out of this loop, then you will press the Control and C together to come out of that. Coming back to this topic over here, each machine has their own IP address, and when they want to go out of, when you type google.com, your machine will look at the IP address of Google and will say, Google is not 192.168. It's not my family. So it's not this, it's not this, it's not this, it's not this. It's outside somewhere. And the only thing it will do is basically it will send the packet to the default gateway. So whenever you're establishing your network connectivity, you always, as a rule of thumb, you always want to ping your default gateway to make sure that there's a connectivity between your machine and the default gateway. And then you also ping some machine outside of the network, outside of your network. So what is my default gateway? Well, how do I know my default gateway? Well, let's see over here. nmcli, and if I see over here, my default gateway IP address is 192.168.1.1. So that's my default gateway. I will press Q to exit out of this. Let me ping this default gateway. Ping. Now I am pinging my default gateway. That means my machine is on the network and it can reach the default gateway. That's looking very good, excellent. I will press the Control C key and I will now try to ping a machine which is outside my network. For example, Google, CNN, Instagram. I know they're not on my network. They are somewhere on the internet. Ping, google.com. Now you see right away, you see this right over here? I want to bring your attention. If I ask you, where did this ping command translated the host name to the IP address right over here, pay attention. The first thing it did is it basically converted the Google's IP address, Google's host name into an IP address right over here. And so if I ask you right now, I want to know how many of you would know the answer to this. Which service on the network, which system on the network did this translation for you? Translated the host name into the IP address. I need every single one of you to give me the answer. Even if you don't know the answer, say potato. Okay? I'm fine with you saying aloo. That's perfectly fine. Now, one person said router, so the other person said potato. Okay, right? Somebody says DHCP. If you are saying potato, you're 100% right. If you're saying DHCP, you're 100% wrong. If you're saying router, you're 100% wrong. If you're saying DNS, you are 100% right. So potato and the DNS, they're both right. Okay, go figure it out why the potato is right. Because I'm hungry. So what did I tell you about the DNS, ladies and gentlemen? The DNS job is to take the host name and convert it into the IP address. Okay? Now these are all of my students that actually do not pay attention to me. They just come over here to see what's going on. They don't pay attention to me. Maybe they're not paying for it, so they don't care. They're like, oh, whatever. You know. So if you look at this, we had this host name over here, right? You did not give any IP address, right? You just simply said ping Google. And then all of a sudden you see that it says ping Google, and then it has Google's IP address. Where did this IP address come from? Which service on the network is responsible for mapping the host name to the IP address? Host name, which is this over here, to the IP address, which is this over here. That service is called DNS. It's called DNS service or DNS system, whatever you want to call it. What is DNS? Is DNS a actual physical device which is on my network? Is DNS a server? Is DNS a software that's running on some server and it's doing its job? What is it? What is it out of all of these? Is DNS a hardware? Number one. Is it a hardware or software? Is it a hardware or software? Okay, great. It's a software running on one of my server, which is, it's a DNS software. It's running the DNS software, DNS server software. Okay, great. Domain name system, okay? Is this a protocol? Yes, it's a protocol. I'm not using the crazy technical language with you guys. I want to keep it, at the low level so you understand that. But DNS is a protocol. DHCP is a network protocol. SSH is a network protocol. What is protocol basically? Well, protocols are also softwares, and they have set of rules they abide by, and they are set of rules the way they work. Okay, so protocols are rules. Okay, but we'll talk about that later on. So now we know how to check whether our machine is on the network or not by using the ping command. The second command I want to show you guys is, okay, that's okay. Is there a way to change my fonts over here? Because I don't know if this is okay for you guys, or maybe I can use a terminal. That's okay. Another command I want to use is basically called traceroute, and I want to say traceroute google.com. These two commands are highly network troubleshooting commands. And they are used by network administrators, by cybersecurity guys, by Linux administrators, Linux engineers, Windows administrators, Windows engineers, or DevOps engineers on daily basis. Like, you cannot live out of these commands without these commands. Traceroute google.com. And I want to take a snipping tool over here and I want to break it down for you guys what Traceroute is doing. Let's take a look at this. Do you guys find this stuff interesting, or do you find this stuff challenging and boring? I tell you, the reason I give you 4 weeks free classes, first of all, nobody ever give you 4 weeks free classes. Nobody has that guts to do this, what I've been doing for the last 15 years. That's because that's straight honesty. I do not want you to be in my program if this stuff does not make sense to you. If it's not making sense to you, if you're not able to build the connection in 4 weeks, there's no way you're going to be in my class. That's the goal number 1. Goal number 2 is you get to see my personality. I'm a dictator type of guy. I like to, reward people, and I like to punish people for their mistakes. And I want to know if you can get along with me, if you can take that fatherly behavior or elder brother behavior and allow me to make changes in your life. Because normally what I do is I get up, and if I don't see my students up by 9 o'clock, I start calling them and I start yelling at them. So if you are that sensitive person and you don't want anybody to tell you what to do, and you don't want anybody to touch you, and you don't, you go down when you hear somebody yelling and screaming at you, maybe me and you were not gonna get along, because I'm all about goals. I'm all about getting my goals achieved. I don't like hurdles. And if you're gonna be the hurdle, then I'm gonna yell at you. I'm gonna scream at you. I'm gonna give you the pep talk, So if you don't, I'm an old school teacher. I'm literally a dictator. I come from a country where there is a dictatorship right now, and it's been a dictatorship, and I am a big fan of the dictatorship. So there's no democracy in my, life. And so therefore, all I care is you getting your job. And how I get you there is my problem, but you got to follow my rules. So now, so if you, don't get along with this, that's something you need to consider, okay? So let's go. Now, people who come from country like I am from, and they're used to the dictatorship, they kind of like this style, So, all right, so I hope I don't get a call from Hafiz Ji. Traceroute is the command to trace your packets. So here, my machine is over here, and I'm trying to reach a machine over here all the way. These 2 machines, okay? The packet is going to leave from my machine and go all the way to this machine. And now my mission is to find out how many routers it has to go through before my packet reaches there. And each router in this case is called each hop. So when I run the traceroute command, the word says it all. Trace route. Trace route. Trace the route. Find how many routers my packet is going through. And so this is the source, this is the destination. In other words, if I wanted to get to google.com from my computer, then my destination would be google.com. Okay? And my source is my computer over here, my computer or my Linux box over here. And when I run the trace route, it's basically going to check the pathway it takes to get to google.com. The pathway basically defines how many routers, how many hops my packet goes through. Why in the world would you want to do that? What's your issue? Why can't you let things happen on their own? Not worry about the number of hops. Well, in most cases, you don't worry about the number of hops. You're only worried if your packets gets lost somewhere, if it's not able to get over there. For example, you type google.com and it just hangs over there. That's when the fun starts. That's when the troubleshooting starts. And that's when you start to dig. So this is problem-solving approach. When you see that, when you type google.com and you hit enter and it's just spinning and it's not doing anything, the first thing that's going to come to your mind is my machine online? So I'm going to quickly get onto my terminal and I'm going to ping my default gateway 192.168.1.1. When I ping my default gateway, I can ping my default gateway. That means my machine is on the network. On my network is okay. Now I am going to ping google.com. Oh, I can ping google.com. That's great. So there's nothing stopping me from here all the way to google.com. Third thing, why my website is not loading or the file that I'm trying to transfer is not doing, then I will look into the traceroute. Now let's come over here. Traceroute will tell you exactly where the problem is. Where did the packet stop? At what hop? So maybe there's a company blocking your packet. So let's take a look at that. There you go. Now one kid is just bullying me again. He's saying, hey, let's have faster over here. Are you guys okay with my speed, or are you guys one of these guys that's trying to bully me over here? Okay. All right. So speed is perfect. Okay. Yo, folks, stop bullying me. Okay. So Traceroute. Hey, Traceroute. Hey, let's trace my route. Back in days, if you're from Pakistan, you would use the word koji. This is what we are doing over here. We're doing the code. We're finding out where did my packet go? What route did it take to begin with? Okay. The 2 stars. I didn't want to show these stars to you guys right now. Let me see once again. All right. Oh, that's ping. Let's do the trace route again. Okay, beautiful. All right, I didn't want to see the star to begin with, so let me do this again. So I started over here. And let's see. You know what? This is interesting. So I'm going to just kind of do this and get another screenshot over here. If you guys liking what you are seeing at the troubleshooting over here, give me a shout out. Let me know that you are enjoying this. If you think this is boring, also let me know. This will tell me a little bit about yourself, whether you are a technologist or you're just a crybaby. Okay. All right, let me see over here. Move this over here. Is it beauty fly or ugly fly? All right, so let's see over here. And Traceroute to google.com. First of all, it translated to the IP address. Who did this part? DNS did this part. Okay. How does my computer know my DNS? Well, it's part of the network configuration. How do I see the network configuration? nmcli. Well, there are other ways to see network configuration. ifconfig. Another command, ipaddr. If I want to see the detailed network configuration information, what's the command? nmcli dev show. Yeah, if you can't do this on the interview, you're walking away with the job. So it says that your packet number 1 hop right over here, the first hop that it goes through is your gateway. Ladies and gentlemen, it's so beautiful. It is so beautiful. My computer is over here. The first thing that I hit on the way to google.com is what? What do you guys see over here? Isn't this talking to you? The first hop that I hit is 192.168.1.1. What is this, ladies and gentlemen? What is this called? This is my default gateway. Default gateway. So now you know any packet that wants to get out of your network or has to get out of your network has to go through your default gateway. Beautiful. Beautiful. And then it says the second router that it hits is basically going to this IP address. And then the third router that it hits over here is basically, if you see over here, it says New Brunswick, New Jersey, B, and then you could tell what type of network I am on. You could tell what type of network I am on. You could tell my ISP who is giving me the internet. Verizon is giving me the internet. And this is the name of their router that's taking my traffic. So from my room to my default gateway to this hop over here, and then to the headquarters of Verizon in North Brunswick, their branch. And then it goes to another internet service provider, customer.alter.net. And then these are the remaining IP addresses. And if you see a star over here, asterisk, that basically means either the router did not want to give its information, or it did not respond in the reply in the timely fashion. It forwarded the packet, but it did not respond. Or maybe it just discarded your packet and then it went to the different one. So a couple of meanings it could have. Okay? So, and now you come over here and you see this is basically probably getting into Google at the end of the day. Okay? Oh, hold on a second. Let me plug in my charger. Give me a second. Why my charger is not... Okay, yeah, I'm good now. Oh, thank you so much. Why yours and my ISPs are coming same way, they are different. Well, haha, good girl, you are on my server. That's why everybody is seeing the same thing, because you logged into my server. Now, let's do the Windows part over here. Tracert. The Windows is tracert.google.com. This is using the IPv6. And what can you tell me about this one over here? This is using, you can use the Traceroute on Mac. Traceroute on Mac, okay? No, you're good. Mohsen, I don't know what you're talking about, but you're good, bro. Altaf is the one who's bored and he needs a coffee break or chai break. Altaf, is it really boring? For you? Okay. All right, so right over here, you could see this is IPv6, okay? Don't get scared. It's going to the default gateway. And then now what can you tell me about my internet service provider over here? Who's my internet service provider over here? And where do you think I am in New Jersey? Somewhere close to East Windsor, and it's Comcast. Okay? Okay, beautiful. And amazing. Do we understand the trace route? Let me show you guys a slide. I have this one. By the way, the updated slides should be there. And yeah, right here. This is something I had to cover from yesterday. So ping and your default gateway is right over here, explained. Okay, and I already explained this stuff to you already in the default gateway. Now, looks too short. Okay, the 7th address does not look like IPv6 though. Okay, yeah, you guys can figure that out. Okay, all right. So we're gonna talk about. We talked about yesterday DNS and DHCP. Today, it's actual introduction to the Linux operating system. Why we are learning Linux. Then we're gonna jump into comparing the operating systems. Then we're gonna look at different versions of Linux. We're also going to look at the market leader. We're gonna look at the core components of Linux. We're gonna get into the core components of Linux. Okay. We're gonna also look into the Linux file system. We're gonna run some commands on the file system. And then we're gonna run some furthermore file system commands. And this is your proper introduction to Linux operating system. This is the roadmap for today. Are you guys with me so far? We talked about what is the role of the operating system in the IT industry. Operating system basically is the interface between you and the hardware. The hardware basically is the server or a laptop or a desktop that you have. And it allows us to run our operations, use these hardware resources effectively, wisely. So that's the role of the operating system. It provides you security, it provides you user management, file system management, system performance. It runs your applications, okay? And the security and access control I already talked about. Resource management is major part of it. All right. You guys are good, or you need a break over here for 5 minutes? Okay, ladies and gentlemen, today we start our journey with the brief history of the Linux operating system. Okay. Linux operating system is a very powerful open source operating system, and it basically runs today's all the infrastructure servers, and it's the backbone of the IT industry. It is the backbone of the AI. How it came into existence back in 1991, one Finnish student from Finland, his name was Nils Torvalds, he had a university research project, and he came up with this idea that the operating system, when you buy the hardware, a laptop, a desktop, or a server, why do you have to pay for the software? You know, at that time, there was Unix operating system, which was proprietary. So there are two terms that we need to understand. One is open source, the other one is proprietary. What is open source? Okay, and what is proprietary? Whatever the spelling is. Open source is equal to free software. We're talking about software. Proprietary is equal to paid. Not only that, open source allows you, so today you're using a lot of open source software. Mozilla Firefox is open source. It allows you access to the source code. What is source code? Any software that you use, it has the backend code. The developers wrote a code in some programming language. maybe multiple programming languages. Usually proprietary softwares like Windows, Mac OS, some Unix, they do not give you access to the backend code called source code. Why? Because they do not want you to copy their stuff. They spent, millions of hours building their stuff. So you will not have access to their source code, the very code that makes their software. But Linus Torvalds came along with this idea. I am going to build a free operating system, a kernel, and I am going to make it completely free. Free to use, free to modify, and I am going to give access to the source code to every individual, whoever wants to get access. And if they have the ability and they want to make changes in his code, they can do that freely. But obviously, they will have to download that code and then they can play around with that code and modify it according to their own requirements, which these proprietary softwares has never given you access to the source code. I think that's the biggest difference between Linux versus Windows, Mac, and some Unix operating systems. They do not give you access to their source code. So if you bought their operating system, like you have Microsoft Windows, and I'm using that too, and if I wanted to add a feature into this and I knew how to do that, I'm a programmer, or I hire a programmer, well, guess what? With Windows, I cannot do that. But if I have Linux and I have the source code available, I can modify that source code and I can use it according to my need if I have, what it takes. That's why Linux operating system is so powerful, because there's not thousands of people, millions of people can make changes in this and make it better and then suggest those changes back to the originator who created the operating system. And then they review those changes. And if they like something, they adapt it. If they don't like something, they will not adapt it. So that's the biggest difference between the traditional operating systems like Windows, Mac, and some Unix operating systems versus Linux operating system. It is open source. Companies love this idea of having access to the source code because they have people who can modify it. Okay. Now, are you guys okay with this stuff? Source code versus proprietary? So Linux is not only free, it allows you to have the backend access to the source code. You can modify it. You can redistribute that to somebody else. And it's entirely up to you, whatever you want to do with the Linux operating system source code. Okay. And let's go back to, are you guys able to see my screen, or am I, the writing that I did over here? I don't think you are able to see that. No, sorry about that. Okay. So, okay. Now we are talking. So 1991, he came up with this idea that it should be a freely available to everybody. You don't have to pay for the operating system. Why you're paying for the operating system when you're buying the hardware? And then the journey goes on, and it's been in operations since 1991 September. And Linus Torvalds basically came up with the kernel, which we're going to talk about down the road. What is a kernel, what is a shell, and what are the utilities? And today it has become the most powerful server operating system because it is open source. And it also started a different era in the IT industry, in the computer science domain, where companies started producing open source software, and because of the flexibility that it offers. So open source was introduced back in 1991. And so why are we going to go through the hassle of learning Linux today? Honestly speaking, it is the backbone of the IT industry today. It powers servers, clouds, internet, infrastructure. Most of the cloud, I don't know if you know about cloud or not, but cloud is Amazon Web Services, cloud is Google Cloud Platform, cloud is Microsoft Azure. Cloud is basically a rental server for all the IT data center. Whatever you can find in the data center, they'll rent it to you online. Instead of buying the physical server, all you need to do is just go to the online store on Amazon or Google Cloud Platform, and you can rent a server for a day, you can rent a server for months, you can rent a server. You pay for what you use. So it's highly flexible, So all of those things are backed up by Linux operating system. At the end of the day, their servers are all running Linux. It's skill is high in demand because it's all command line and there is a learning curve. Not everybody is up for that challenge to learn it. And I think anything that is a little bit more challenging is going to make you unique. And, so therefore you will have a respect in the industry and you will have job growth. And now AI models, they are actually preferred to run on the Linux operating system, even though Windows can run it, but they are preferred. The preference is Linux because of its resource management. Okay, so it's basically taking over the entire data centers. And I've been telling you about this, and I want you guys to do your research on this, that the number of data centers are going to explode. The number of applications that me and you use, because now every average Joe can get on a Claude or ChatGPT and create any application they want as long as they have this crazy idea. And they can create the applications, but they still need servers, data centers, in order to host that application. And the number of servers explode, the number of opportunities in this domain are going to explode. AI cannot take over this job, not at least for another 10-15 years, because it's not that mature yet, and plus it requires working with the physical bare metal servers, and it requires multiple skills. Not only Linux, you need to know about Ansible, you need to know about other DevOps tools. So it's a multi-skilled domain that we are in. Therefore, it's going to be very difficult for AI to replace these skills, at least for some time. Okay. So Linux is basically the infrastructure OS for all of these things that we talked about the other day, DNS, DHCP. The preference by the system engineer is to go with the Linux operating system. All right, so we're going to continue. This talks about the demand. It talks about how it powers the world, how it's free and open source, how it's secure and reliable. Its resource management is amazing. And there's the career growth, and the community and support is there. All the good stuff you can go through. The market share over here, the desktop market share basically means the number of people using Windows operating system versus Mac versus Linux versus other operating systems. If you look at the desktop market share, that is absolutely right. 72% of the organizations are using Microsoft operating system for a laptop, for a desktop. But if you look at the server market share on the right side, same, 72% is Linux and 23% is Windows. And it is still transitioning from 70 to 100. At some point, it's going to go there. Okay. And your Android OS is also powered by Linux. And all the cloud providers, the cloud infrastructure, AWS, Microsoft Azure, Google, they're all running on literally Linux operating system. Okay, so it's a really powerful operating system. It's worth learning. It has great career growth for you. We talked about the open source. What is the exact? Okay, We talked about the open source software, right? Open source software, give you a little introduction about that. The open source software allows you to have access to the source code. So anyone can review the code, use the code, modify it, and share it. It's built by communities, not just by companies. It powers most of the technology we use today. And most of the technologies that actually we use today, the web servers that you hit, the google.com, and pretty much all the technologies that you unknowingly interact with, they're all powered by open source. Open source softwares are taking over this IT industry, and they're free. You can become expert in any one of these technologies, and you can sell your services. This course is not only going to make you good at Linux, it's also going to open up doors for other opportunities when you understand things, how they are connected, how to work with the operating system, how to work with the applications, how to do resource management, how to work with the virtualization, cloud, security, and automation. Then once you're expert, you get started in the industry, you will start to look at different open source projects and maybe become certified in some of the open source project and start selling your services to the clients. And I have so many friends that are doing this. I have friends who are in the cybersecurity domain. I have friends who understand the systems, and they are good at certain things, and this is what their domain has become, and they provide their consulting services to the clients. So it's going to open up doors for you in many, many directions, not just the job, okay? So understand that the open source gives you transparency, it gives you trust, there's no cost associated, there are community, millions of people working on the same project, so there's innovation every day happening, and the software is getting improved, okay? And let's look at some statistics. 90% of the cloud runs on the open source, 96% of the top 1 million web servers run Linux, okay? And so open source, some of these open source projects are on the right side. There's Linux, the most popular one, then you have Git, then you have databases, then you have Docker, which is very popular. Kubernetes is highly popular right now, and Firefox and TensorFlow. These are some of the most popular open source projects. So compare operating systems, okay? So honestly speaking, the most adapted operating systems in the IT industry. At the desktop level, you can have Windows and Mac. On the server side, for the most part, you're going to see Linux, which used to be Unix operating system, but now it's all transitioning into Linux. You will see Linux operating system, maybe some window boxes. Boxes means machines. And maybe some Unix, which is basically fading away. It's in the phase of being retired. Unix operating system used to be very powerful operating system, but open source killed it. So Windows is proprietary, Mac is proprietary, Unix, most of the OS is, most of the flavors or distributions are proprietary. Linux is not easy to use, but nowadays it has beautiful graphical user interface. Windows is very easy to use, Mac is very easy to use, and same thing with Unix is very difficult to use. Multitasking means you can have thousands of people log into the same server. And for Windows multitasking, yeah, multitasking is there, but you may have to buy licenses. And for Mac, multitasking is there too. You can all get into the same server. Unix also allows you to do multitasking. Is Linux open source? Yes. Is Windows open source? No. Mac open source? No. Unix, some versions of Unix are open source. Security wise, you get 5 stars on Linux. It's the most secure operating system, okay, on the planet right now. And then you have Unix, and then Mac, and then Windows is at the last. Cost wise, it's completely free. For Windows you have to pay, for Mac you have to pay, for Unix you have to pay depending on what version you go with. Performance wise, how well it utilizes your resources on the server. It's excellent performance with Linux. That's why engineers, DevOps engineers, Linux engineers, they love, their choice is Linux operating system. Cybersecurity guys love to work with the Linux operating system. Developers love to work with the Linux operating system. And so performance-wise is high performance, Windows is moderate, listen, if I show you my resources on my machine right now, I got 64 gig RAM on my new toy over here. The beast that I got for $6,100. Guess what? 45% of my resources are being utilized just to broadcast my video to you guys. Yet the video quality is not that great. Welcome to Windows. Okay. But I don't know, for some reason, I still like it for my desktop because of the ease. Not ease for me, I can comfortably work on Linux operating system. The issue is the compatibility. The softwares that we use on day-to-day basis may not be compatible on Linux operating system. Okay. So it's not on a consumer level. It's only good for server level, because you don't throw on a server, you don't throw all these stupid Netflix and all that, stuff on your servers, right? Okay. Are desktops starting to adapt Linux more? Yeah, I'm going to talk about why Unix did not get the market share. Unix is very powerful. For servers, it was doing amazing thing. But when Linux came into existence, it killed Unix because it's his rival. It's basically based on Unix philosophy, command line. But the open source was a game changer. So Unix died and Linux took over. I was a Unix certified system administrator back in 2003. And then I transitioned into Linux administration and Linux engineering because we were just getting rid of the Unix. Who wants to pay money? People want to run free operating system. Well, there's more to the story for the free part, okay? Don't get too excited. Okay. Market share is 4% for the desktop, which is wrong, which is about 20%. 4% for the desktop. But market share for the server, Linux is 70%, the leading operating system. And so Linux is best for servers, cloud, DevOps, and developers. Windows is good for general user, home. And Mac is really good for creative professional designers and developers. And Unix used to be really good with the enterprise systems, but now it's just a legacy system. Still very mission critical servers, you can run Unix operating system. 90% of the cloud runs on Linux, 96% of the web is backed up by Linux. Number one choice for the security and the freedom is Linux. And most important thing is open source. And I talk about this already, that there are trillions of dollars being spent in the data centers, and we are already starting to see a lot of data center jobs. And data center job is very easy job. Data center technicians will pay you around $80 to $90 to $100,000 nowadays. And all you need to know is the stuff that I already shown you. How to work with the bare metal servers. How do you open the lid? How do you replace the parts? How do you rack and stack those servers? How do you do the cabling? How do you connect to the switch? How do you connect to the router? How do you run the patch cables? What type of different cables you know about? What do you know about the storage part? We already pretty much have given you that knowledge. So if you are interested, and if you learn thing or two from my free classes, go check online, maybe Amazon, maybe Oracle Enterprise Linux, maybe Red Hat is hiring data center technicians. And on top, the amount of Linux that I'm going to teach you, you might be able to get a $70,000, $80,000 starting salary without any experience in the data center domain. Data center technician is a job role. Go check it out for me, okay? If you have a work authorization or green card, yes, absolutely. You have to have a work authorization. The citizenship is not required for the data center roles. Citizenship is only required when you are working with the federal government or state or city jobs, or some jobs require security clearance. So any of you that have experience, you work in the law enforcement, or you were part of the army or veterans, if you're a veteran, you're gonna get a lot of attention. You're gonna get a lot of job opportunities because you have the highest level of security clearance. And after 5-6 years, you can make crazy amount of money working as a DevOps engineer, system administrator, system engineer, just because you have security clearance from the government. There's a process of 6 months. They look at your entire life, what you did. But obviously you cannot lie about anything. You have to have a solid work history for 5 to 6 years. You can make decent amount of money. They usually pay north of $70, $70, $80, $90, $100, the government projects, okay? An hour. Well, obviously, if they refuse you because you have a green card, maybe there's something wrong with your resume or you did not portray it the right way. So look into those data center technician jobs for me at Amazon, Oracle, Enterprise, Linux. Go to their website. Maybe they have internship opportunities because they're hungry for people that can actually work with these servers, bare metal servers. And the servers that I talked about, even just put on your resume that I know I have attended this boot camp, and from there I learned this. I know Linux, I'm good with the Linux CLI. Wait for these 4 weeks to conclude. You can start putting your resume. But if you're transitioning to the paid program, do not play with your resume right now. Now, because Linux is open source, anybody can download, anybody can play with the source code, and anybody can create their own operating system. Therefore, Linux has variety of operating systems. There's no one such, what I can call it a distribution, are different flavors of Linux. Just like the ice cream has different flavors, Linux has different flavors. And some of them are Ubuntu, Debian, Fedora, Red Hat Enterprise Linux, SUSE, Oracle Linux. They're all Linux operating systems. They all have the Linux kernel, but they're slightly different. Maybe the interface, the graphical user interface is different. Maybe slightly their commands are different. Why? Because these were all the opportunists. These companies like SUSE, Oracle Enterprise, Red Hat, they came and they realized, oh, we can take this and we can brand it under our name. Just like if you are in the flower business, you take the flowers and you make any type of bouquet you want and you have it under your own brand, right? And so these opportunists, these companies, they started in maybe 80s, and then they started branding. They took the operating system from Linux Torvalds and they made some modifications here and there, and they branded under their own name. And that's why you have a lot of distributions on the Linux side. If you want to work with as a cybersecurity guy, you would be working with the Kali Linux. If you are an enterprise company in the United States, you will be working with the Red Hat Enterprise Linux. You might be working with Oracle Linux because now the government is doing a lot of contracts with the Oracle Linux. Okay, so we'll talk about these distributions. Is everybody with me so far? I know it's getting a little boring. I know you guys are used to the 5 seconds, Instagram videos, and somebody just gets your attention in 5 minutes. If you don't like it, you just swipe through it. Unfortunately, this is about your life. Enough of swiping, up and down or right or left. This is about your life. You don't have the opportunity to swipe me away, because I'm going to put the money in your pocket. I'm going to make you powerful. I'm going to make you more respectful in your life. Because honestly speaking, 70% of your problems will go away when you have money in your bank. 70% of your problems will go away. Your loved ones, your family members, your friends, they will start to love you more if you are that person who is in demand. You will have respect at work as well because you have a skill. So, unfortunately, you do not have the opportunity, or rather choice, to swipe me up or down. You're stuck with me for some time, all right? You like it or not. Now, we're going to be focusing on summary of the enterprise Linux, okay? Understand. These operating systems, Red Hat, SUSE, Oracle, they're all used in the enterprise environment. And the Red Hat is the number one on the top. It's the market leader. And then you have Oracle as well. Ubuntu is used in a lot of research companies. It's being used by researchers. It's used by universities because it's completely free. Red Hat, SUSE is very popular, or SUSE is very popular in Europe. In North America, I would say Red Hat is the leader, and that's why we primarily focus on Red Hat. But the funny thing is, what Oracle Enterprise did was they copied the Red Hat operating system word by word, and then they just changed the logo to Oracle Linux, because the open source philosophy says if you make something with open source, you gotta give it to other people. And so they were smart. What they do is they just copy everything the Red Hat does, and they have the people who are smart enough to support it. So if you know Red Hat, you can claim to know that you have the Oracle as well on your belt as well. But the certification and the industry is looking for Red Hat people. Oracle, you will put it on your resume as well because it's word by word same thing. Okay. What version of Linux should we install as students? Oracle. We'll talk about that, okay? So, talking about this, let's go onto our command line and let's figure out what distribution we're using over here, the server access that you have. So the command for that is hostnamectl. Hostnamectl. And if you come back over here and you see hostnamectl right over here, the command, it gives you some good information. This is the server 101, that's the computer name. It's actually a server. It's a bare metal server. This is the make and model. Oh, you guys cannot see my screen, my bad. My apologies. Okay. The machine ID number, none of this matter. Operating system distribution. What does it say over here? Oracle Linux 9.7. And then it has the kernel version over here. We'll talk about the kernel. It tells you the hardware vendor. You guys can see my screen now, right? So the command is hostnamectl. Okay. Another command that I gave you, okay? It's an excellent command. Whenever you log into the server, you always want to run the hostnamectl command to see what type of server you are on. It tells you this is HP server. This is the make and model of the server Gen 9. And this is the version, the distribution that you're using over here. So now you know the word flavor and distribution. You know, and So on an interviewer might ask you what flavors of Linux you guys are using in your shop. The lingo is very, very important. And you would be like, what? Flavor? Shop? What is he talking about? Basically means what you guys are using in your organization. So the lingo is very, very important for the interview, and you need to have the same lingo too. What distribution you guys are using in your shop? Well, we're using Oracle, we have Red Hat servers too, we have some Ubuntu servers too. You got to be able to answer the way they expect. Okay, let's continue with the slides. Can you explain this command again? Hostnamectl. Of course, I can explain that here. So we run the command hostnamectl right over here. The first thing it shows us the host name, which is server 101. And then it talks about the computer is a server. It's a server, it's a chassis server. Then it gives you the distribution over here, the distro, also called flavor. And then it tells you the kernel version right over here. And then it gives you the machine information, the underlying bare metal server. This is an HP server, ProLient DL580. Those of you who are interested in the data center technician jobs, you need to know that you work with the Dell DL580 Gen 9 HP. Okay. Great job. All right, so because it's Mother's Day, I'm gonna keep this. When you install Linux at the end of the day, basically, the main program in Linux is called kernel. It is kernel right over here. The kernel job, ladies and gentlemen, right over here as it says, it's to manage hardware resources. It's to manage the CPU, the RAM, the hard drive, all the hardware resources. So kernel basically does the process management, memory management, device management, file systems, network stack, security enforcement. So when you install Linux, ladies and gentlemen, let me draw this over here. You basically, when you take a DVD or USB, you plug it into your bare metal server over here, right here, okay? You plug it into this bare metal server, and you go through the installation process. You installed, let's say, Linux on it. What this is going to give you is two components. Linux will come with two components. One is the shell, the other one is the kernel. When you install your Linux operating system, you have two core components of Linux. One is shell, the other one is kernel. When you are interacting as a regular user, here you are. It doesn't look too happy. You are on your laptop over here, just like you connected to the you own your laptop, you connected to the os.linux.us. What you see is basically the terminal. This black screen over here called terminal. This terminal is called the shell. Yeah, today for here. Somebody complained yesterday. Okay, so you have two components. One is shell. So for example, right over here, I am interacting by typing my commands over here. I am interacting with the shell. As a regular user, as a user of Linux, I am always working with the shell. At the back end, whenever I type any command, for example, I type the command uptime. If let's say I type the command lscpu, this command I entered into the shell, which is core component of Linux. The shell took this command and sent it to the kernel, another core function of Linux, core component of Linux, kernel. What is kernel's job? Kernel's job is to manage hardware resources. That's it. What is hardware resources on a server? CPU, RAM, power supply, hard drives, network cards, RAID cards. These are all hardware resources on your server. Whenever I want to read a file, whenever I want to write a file, whenever I want to send a packet through the network, I will type that command into my shell. That's one core component of Linux. That shell will take the command and pass it to the kernel if it has anything to do with the bare metal server at the end of the day. So let me ask you this question. When I type the command ping, answer this question. When I type the command ping, does it have anything to do with the hardware resources on my server? Does it involve any physical parts? Some of you guys are saying no, some of you guys are saying yes. First of all, I type the command ping google.com in my terminal. Correct? I am interacting, I am working with shell. You got that part right? I am working with shell. That's number one core component of Linux. Number two is, as soon as I hit this command, is the server going to process this command through the memory, CPU, and the network card? Talk to me about this. Anything that you run on your server or on your Windows machine, it has to go through your memory, your CPU, and your VGA card, or maybe network card. So why you said no? When I hit that command, the command will be written on the terminal. That's the shell part. Then the kernel will take that command and will feed it to all the CPU resources that it needs. It will push into the RAM, it will push it into the CPU when the time is appropriate. So under the hood, whatever is happening, who's the core responsible for those operations? Say that out loud. Kernel. So under the hood, whatever is happening, wherever the hardware gets involved, wherever the network card gets involved, the CPU, the RAM, pretty much for everything that you do, kernel gets involved. And that's under the hood. Yes, we can see that communication if we want to, but shell doesn't want us to see that. Shell is like, hey, just give it to me. Give me what you want. You wanna send packets? I'll send it to kernel. Kernel will take care of it. You don't have to write the low-level programming languages for the kernel to do that. Somebody has done that work for you. So there are two components to your Linux operating system. One is the shell. Shell is the interpreter between you and the machine. Hey, this is shell right over here, the black screen that you're seeing. This is shell right here. This is shell. And the other one is the backend guy that's doing the actual work, making sure the hardware resources are doing their job right. If it's a network packet, then it's going to go through the network card. It's going to go through the it's going to go to the hard drive. Whatever you're doing. If you're creating a file, you need to use the memory. You need to use the CPU. You need to use the hard drive. Right? All of those things are being done by the kernel. So if I ask you, this is an interview question, by the way, 2 core components of Linux operating system, what is your answer? Two core components. Some of you just giving me one, shell and the kernel. Now, I ask you furthermore, what is shell's job? Give me the shell's job. What does shell do? Somebody says command line, it takes the commands. It's an interface between you and the machine. It's an interface between you and the kernel. It interrupts your commands. It takes the input from you. Whatever you need to do on your Linux machine, you will type it in your terminal in a layman language. And kernel will do all the backend operations. Okay? When to hit the hard drive, when to hit the CPU, when to hit the RAM, when to hit the network card, or when to hit the video card. All of those things are being managed by kernel. So that's called hardware resource manager. What is kernel job? It's a hardware resource manager. It manages the hardware resources. Beautiful. Beautiful. You could never get these two wrong. You could never get these two wrong, because if you do, you know what the dictator is going to do to you, right? Because this is a legit interview question. And I have seen some of my students not get it right. Now, if a student does not get this right and they're interviewing with Morgan Stanley, do you think that's my problem? Do you think that's my problem? Obviously, it is my problem because they're my students, but you can do so much with people talking about success and unsuccessful stories. If you're somebody who's coming over here, taking this class on daily basis, you're not practicing for the interview, you are going to be unsuccessful. 100%. There are no lies about it. You need to spend minimum an hour. And if you want to be super good, 2 hours with the command line. Your fingers need to talk. When you think about doing something, your fingers will do it for you. You don't have to process that thought in your kernel. So what is the shell in my body? My face, my ears, my eyes, their shell. What is the kernel of my kernel? What is my kernel? My brain, my 6 senses, maybe my other organ. I don't know, we can argue about that. My heart. Beautiful. Love it. Now we know these 2 things. And I also want to tell you one more thing, that there are different types of shell. Shells are like languages, the way terminal understand your commands. It's like an environment provided to you. So you have a choice. You can use the bash shell, which is the default shell every user gets when their accounts are created. You can choose the K shell, which is corn shell. You can use the C shell. Usually the programmer type of people, they get fancy with these shells, but for the most part, we will be working with the bash shell. This is the default shell that is installed on Linux versions and is available pretty much on all the distributions. And when you create a user account, by default, the user gets the bash shell. Now, we talked about 2 components, 2 core components of Linux. One is the shell. Let's just see how it says. It's how you interact with Linux. You type commands, run programs, and get things done. The other one is the kernel. It's the core system. When Linus Torvalds developed Linux operating system, actually Linux kernel is the operating system. Shell is a program written by somebody else. The core operating system is the kernel, which was written by Linus Torvalds. And then everybody else joined and said, hey, I can write the shell. Hey, I can write a graphical user interface. Hey, I can give you the Chrome browser. Hey, I can give you Firefox. Everybody joined in hands. And then utilities, those are utilities that are built on top of the operating system. I mean, Microsoft Word, Mozilla Firefox, Google Chrome, are they part of my operating system? No, they are not. What are they? They're utilities, they're programs available for users to take advantage of. So, once again, say it out loud. What is shell's job? It's the interface. What is kernel's job? Hardware resource manager. Hardware resource manager. That's it. And I have beautifully illustrated. I spent so much time on these slides. I sit and I think and I come up with these crazy ideas. Do you guys like my slides? Nobody appreciates the slides that I have created for you guys. All right. I don't know if you guys like the color scheme. I like dark colors and but these are my creations. I didn't copy paste from anywhere. Okay. So now we know two things about the shell and the kernel. And they are both part of the operating system. How would I know what shell I'm using as a regular user? How would I know what shell am I using? So this is the command over here. Echo $capital shell. Go ahead, run this command for me. Echo space $shell. That's the command. And then you will see the output bin bash. That means you are using the bash shell. Was everybody able to run this command? Echo space $capital shell capital bin bash. It is case sensitive. Linux is case sensitive. Okay. All right. We got these commands. Now I want to know what version of kernel I have, because kernel is a piece of software that gets updated. And so I want to know what is the kernel version that I'm currently using. The command is uname-r. Uname-r. When did we learn that? Next class will be Wednesday, terminal disconnected. Troubleshooting networks issues. We learned today, in the ping command and the traceroute command and the nmcli and the network connectivity. We learned that today. Yeah. So now you see uname-r will give you the kernel version right over here, 6.12. 6.12. What is this command showing again? It is showing the version of the kernel. Kernel is a software, right? It's the main software. It's the main piece of software in Linux. Linux is the main umbrella, and underneath Linux, you have small, tiny, hundreds and thousands of softwares. The main software that makes Linux work, the minimum two things that you need is a kernel and shell. And they are independent software packages. They are programs. If I remove kernel from my Linux, can I work with my operating system? No. If I remove shell from my Linux distribution, can I work with my Linux? No. So in order for me to see what shell am I using, I will use the command echo $shell. Oh, I'm using bin bash. Okay. What is the version of the kernel software that I'm using? uname-r. And the uname-a will give you all the detailed information, by the way. Let's take a look at the uname-a. I feel like you guys are so bored right now. You just want to quit and leave and do something better with your life. Like, eat some ice cream or have some halwa puri or, some some Nihari. Yeah?